Our topic for today is going to be on the continuation of non-metals we have started before, and specifically the element we are going to focus today is going to be on nitrogen. So we talk about details of the occurrence of nitrogen, the preparation, and some properties, and we have to take a step further into the subject of some common properties of compounds and some properties of them and how to prepare them. Of course, as usual, the way we used to do before every of our lecture, we state our learning objectives, and today is not going to be any different. So after this class, students are expected to be able to describe the properties, the preparation and uses of nitrogen and some of its compounds. As case may be, we are still expected to discuss some chemistry of some of this nitrogen and this compound and what is responsible for the way a particular one of them behaves. This is our periodic table, and we are quite familiar with it. And this is the nitrogen in the group 5 period 2, and we are familiar with it, the seventh element of the periodic table, and electronic configuration should be 2,5. That is why it is on group 5 and period 2. It belongs to the P block of the periodic table because it's a non-metal and the mass number is 14. So let us start by virtue of introduction. In the atmosphere, we have mixture of gases. We have the CO2, very small quantity, like 0.03%. We have oxygen, around 21%. We have some mixture of inert gases and some impurities and water vapors in the atmosphere. The gas that occupies the most volume in the atmosphere is nitrogen. This nitrogen occupies up to like 78% by volume. What we are trying to say is this: if you have a square mile, in a square mile, let us assume that we have 100 tons of air. So 78 tons is going to be nitrogen. You can see how large it is. The function nitrogen is performing in the atmosphere is to act as a diluent to the atmospheric air, because if there is no nitrogen, this world will not be a safe place to stay, because that small oxygen, that 21% of oxygen, is enough to burn the whole Earth's surface. But thank God for the very large amount of nitrogen that is there to prevent the oxygen from combustion. And this nitrogen is the major source of nitrogen is from the fractional distillation of liquid air. Liquid air is when you the cold liquid here, you have liquid here. That liquid when you do fractional distillation. We are doing fractional distillation because each of these components are close to each other in boiling point. So when you do fractional distillation, you get nitrogen. That is the most pure forms of nitrogen, the form of nitrogen. So any other form is not as pure as this particular form. Nitrogen is by nature a component of some proteins and genetic materials of plant and animal. All the genetic material we have been hearing of RNA, that is ribonucleic acid. We have been hearing of DNA, that is deoxyribonucleic acid. All these genetic materials are made up of nitrogen compounds, and they are in plants and animals. You can see how important nitrogen is, apart from acting as a diluent in the atmosphere. Under standard conditions, nitrogen is a colourless gas. It's a gas that is colourless, it's odourless, and it's tasteless. So the boiling point is 77 Kelvin and freezes at 63 Kelvin. You can see how it is a gas in the atmosphere, and how low it can be subjected to in terms of temperature. Liquid nitrogen is very useful because we have highlighted the useful in the atmosphere now, the usefulness in the atmosphere now. We have highlighted the usefulness to nature, and again, in industrial process, it is used as a coolant because look at this temperature now. This temperature is very low, so it is very good as a coolant because it doesn't. At that temperature, that coolant is expected to work. That nitrogen will be liquid at that particular time, so it will not vaporize easily. So, and again, it is inexpensive. It is, we say in the atmosphere it is almost 78%, so you can get nitrogen as much as possible. So to be used in the industry for this purpose, I think nitrogen is a very good choice because of the abundance and the chemistry of its reaction. Nitrogen again is very unreactive. If we draw the electronic configuration, we have 2, 5. We say the first shell contains 2 electrons, the second shell contains 5 electrons. And don't forget that to complete the outer shell, nitrogen needs 3 electrons more to complete the outer shell because it is a non-metal. We don't expect nitrogen to give out its 5 electrons, so rather it takes 3 electrons from other elements. So if it doesn't take, because there are times that it reacts with a metal, like lithium, to form lithium nitride, it reacts with some other metals like sodium, like potassium, it reacts with hydrogen, sometimes it reacts with oxygen. But our own focus is only the reaction with oxygen in this particular course subject. So now, if nitrogen will now react with any other element, it needs 3 electrons to share with it if it is a non-metal like oxygen, like hydrogen. So if it is a metal, it is transfer of electron is very easy. So it just gets 3 atoms of lithium to attach to it. 3 atoms of lithium has transferred each 1 electron each to make the bond complete. But if nitrogen is attracting itself to another non-metal, there is going to be a sharing of electrons, and each of them will complete their outermost shell. In this case, another case is ammonia, and that is an example. That is when nitrogen needs 3 ammonia atoms to complete its shell to be completed. So nitrogen will have 8 ammonia, each of them will have 2. And again, if nitrogen wants to combine with itself, one nitrogen needs 3, other one needs 3, so they can combine together to form nitrogen molecule. So that will now result in a triple nitrogen bond. That particular bond is very strong, and it makes nitrogen to be unreactive. So those are the things that make nitrogen to be useful in nature and in industry. The general lack of reactivity of nitrogen makes it remarkable ability of some bacteria to synthesize nitrogen compounds using the atmospheric nitrogen gas. This process is what is called nitrogen fixation. What we are trying to say here is that nitrogen is not reactive, so it is in the atmosphere. It will just be there. It won't react with oxygen. And then being is reactive now, the plant and animal will not be able to synthesize their food through nitrogen. So now, when we now have unreactive nitrogen in the atmosphere, there are some bacteria in the soil, especially in the root nodules of leguminous plants. They fix that nitrogen and convert that nitrogen into some useful nitrate in the soil. So such nitrate will be absorbed by the plant in the soil. Then other bacteria will also act to it and release it back to the atmosphere after assimilation has taken place. So the cycle will now continue like that. That is what is called nitrogen fixation. Another one is during thunderstorm. A thunderstorm can make nitrogen and oxygen to react. That reaction is driven by light of thunderstorm. So when you have something like that, there is going to be reaction with water in the atmosphere. Also, they form nitrate salt. A nitrate salt goes into the soil. Then the plant absorbs it. When the plant absorbs it, they use it to manufacture their food, then or the leftover will be turned back to nitrogen gas, that is the nitrifying bacteria. Then again we have the cycles continue like that to keep the balance in the ecosystem. We can see the importance of nitrogen is not to be overemphasized. And again, the industry, fertilizer is very, very important in agriculture. So to make to boost the product of agriculture, we need fertilizers. So now fertilizers are being produced from ammonia. So the major source of ammonia is nitrogen. So we use nitrogen to produce ammonia. Ammonia is being used in turn to produce fertilizer, which is very, very important as far as agricultural sector is concerned. So these are the forums the uses I've explained. And the one I've not mentioned is the inert nature of the atmosphere, the nitrogen, which makes it useful in preservation of canned food. Because if you have a canned food and we don't have something like inert medium to preserve it, it is very, very easy for bacteria and other microorganisms to enter and oxidize the food and destroy and spoil it. So now if you want to now preserve those canned food, all these tin tomatoes, other canned foods like tin tomatoes, like sardines, like gizzard, all those things. So we want to preserve them. They store them under nitrogen gas. So nitrogen gas will prevent the microorganism from oxidizing it because nitrogen is not reactive. That is it. So let us try to go to some compounds of nitrogen. I've said it that nitrogen belongs to group 5 element and it's a non-metal. So we expect ordinarily that the oxidation state of nitrogen is -3. But research shows that nitrogen can have oxidation state from -3 up to +5. And each of these oxidation states can form compounds with it, although some are not stable. So we are not going to concern ourselves with the unstable ones. It is only the common ones that we are going to concern ourselves with. How to produce the simplest nitrogen compound, that is nitrous oxide. Nitrous oxide is nitrogen 1 oxide, that is when the oxidation number of nitrogen is 1, N2O. It is produced from ammonium nitrate. When you have ammonium nitrate heated, then you are going to produce nitrogen 1 oxide, that is dinitrogen oxide. Then water vapor is going to form. So if you continue the heating, then we have nitrogen gas, oxygen gas and water vapor. Although this reaction is not something to be practiced at home because of reported case of loss of life and some destructions that has been reported. I could remember in 1947 in Texas City, this nitrous oxide has caused an explosion. Many people died and some properties were lost. And even in 2013, the same Texas, West Texas, there was another reported explosion from nitrous oxide. So in the world all over, there are more than 30 million people that have died because of the explosion of this. So it's a very, very dangerous reaction. It should not be tried at home at all. So another one is the nitric oxide, that is nitrogen 2 oxide. You can see the oxidation number of oxygen is 2. So if you employ our knowledge of oxidation state, we are going to see that the oxidation number of nitrogen here is 2. So in this case, we have talked about oxidation number of nitrogen to be 1. So now it is 2 now. So nitric oxide is a colorless gas with a pleasant odor and sweet taste. So this particular compound of nitrogen is gas, as I've said, and it's very, very useful especially in medical practice, where it is being used as anesthesia. This anesthesia is when somebody wants to be operated on. They use this nitric oxide like something that make the cell around that place to be temporarily died, so the patient can be operated on without feeling the excruciating pain of being pierced through the knife. to produce this nitric oxide, we can react oxygen and nitrogen with it. Don't forget I said there is ordinarily nitrogen is not reactive, but this reaction from lightness, I've explained earlier, oxygen can react with nitrogen to form nitric acid, nitric oxide rather. This nitric oxide is as I've explained. So using this method, it is going to be a low yield, but nitric oxide is going to form. So to venture into that as a scientist is not going to be productive because of the low yield. So instead of that, so scientists now use another convertible method that yield that have a appreciable yield, and again is very easy to produce in the laboratory. What they do is reaction of copper with dilute nitric acid. So when you have reaction of copper and dilute nitric acid, is going to be heated. So when there is a reaction like that, nitric oxide is going to be produced, and nitric sort of copper, then water is going to be produced. This is a particular useful reaction in the laboratory. It is very, very important reaction, and student needs to understand it very, very well. So these are some of the properties of this nitric oxide. At room temperature, the nitric oxide is a colourless gas consisting of a diatomic molecules. It's a diatomic molecule because of the unpaired electrons that is in the nitrogen. If I don't want to write the electronic configuration, because we have talked extensively on electronic configuration and how to react together. So now in this case, it is now your duty to write it so that you write the electron of nitrogen, you write that of oxygen. Don't forget, in this case, oxygen, one atom of oxygen is reacting with one atom of hydrogen. So if you look at that, there is going to be two leftover electrons that are not reacted. Those two leftover electrons are called unpaired electrons. This unpaired electron is ready for any reaction from any substance. So in this case, if you have nitric oxide from one compound, we have another molecules of nitric oxide. So when you have reaction of them together, they form what is called a dimer. That dimer contains two atoms of nitrogen, two atoms of oxygen, and is courtesy of the unpaired electron in the two nitric oxide molecule. And again, some of the unpaired electron, what we have discovered is that the paramagnetic, their gas are always colored because of the absorption of light. But in this case, despite that it contains unpaired electron, it is not colored, simply because the absorption of light of this one is not in the visible region. So if it is in the visible region, we will have seen it that it is not, it is also colored, it is green, this is green, this is black, or this is brown. We're going to see, but in this case it is not in the visible region, so we didn't see anything. We saw it as a colorless gas. Another compound, nitrogen 2 oxide, nitrogen 4 oxide rather, that is nitrogen dioxide. This nitrogen dioxide is prepared in laboratory by heating the nitrate of a heavy metal. So you can choose any heavy metal you like. It can be nickel nitrate, it can be copper nitrate, it can be zinc nitrate. Don't forget, we said it before, that all nitrate are not stable, they are decomposable by heat. So if you have a nitrate of a heavy metal in this case is all these transition metals. As I've said, I have used copper now, I've used zinc. You can use nickel also, you can use mercury also. There are many heavy metals that you can use. So when you have when you heat that nitrate salt, you are going to get the oxide of that compound. If you use copper nitrate now, you are going to get copper oxide, you are going to get nitrogen 4 oxide, then an oxygen. That's what you get. So if you use another nitrate of another sort, you are going to get the oxide of that compound, then nitrogen 4 oxide. That is our bone of contention, that nitrogen 4 oxide that we are going to get. So every other product we are left concerned with it. It is brown in color. And again, another method that is being used, this one is in the laboratory. You can have reduction of concentrated nitric acid with copper. So this concentrated nitric acid is an oxidizing agent. Copper in this case, because it's a metal, is a reducing agent. So if you add copper metal to it, there's going to be exchange of ion, like we have in this equation now. Assume this is copper now, this is but in this case is dilute. So let's assume we have a concentrated HNO3 here now. There's going to be something like this. Instead of 8 here, because it is dilute, it's not going to be 8, it will be around 2 or 4. So in that case, we will not have up to this amount here. So we have NO2 here. If you settle down to write the equation, you're going to get it. So schematically, this is the diagram. This is the copper metal. This is the concentrated HNO3. So when you drop it together, there is going to be a reaction. It forms copper nitrate, as I've said. It forms copper nitrate, but not going to be as much as this. There is going to be water, definitely, because you have this hydrogen that is here. There are going to be NO2 instead of NO here. There are going to be NO2. This NO2 is brown in color. Copper nitrate, because it's copper, it is green in color. This is what we have here, and the color of this gas is brown in color. It is commercially we can produce nitrogen dioxide by oxidizing nitrous oxide with here. Nitrous oxide that we just said here, this nitrous oxide, if you have it with oxygen now, we can add oxygen to it and produce nitrogen dioxide. That is what we are trying to say here. Some of the properties of this nitrogen dioxide is that the nitrogen dioxide molecule contains an unpaired electron, like we have it in nitrogen 1 and 2 oxide, which is responsible for its color. In this case, it is colored now because of this unpaired electron. Don't forget the reason we gave why that other one was not colored. So it is also paramagnetism, and it's a dimer. It exists as a dimer. So when you have nitrogen dioxide, you can have another nitrogen dioxide molecule to form dinitrogen trioxide. So at low pressures or a high temperature, it has a deep brown color, like I've shown here before in the previous slide. At low temperatures, the color almost entirely disappears as this dinitrogen trioxide forms, because at low temperatures, that is at high pressure, there is going to be reaction between two nitrogen dioxide molecules, that is dimerization. So we have this one is not colored, that is why the color disappears. So at room temperature, there is going to be an equilibrium. Equilibrium is when nitrogen can form a dimer, nitrogen dioxide can form a dimer to form this, and this one can also decompose to form nitrogen dioxide. That is equilibrium that exists at room temperature. Any other temperature that is not room temperature is either going to be product side or the reactant side. We have talked about equilibrium before. So another compound we are going to treat now is dinitrogen trioxide. How dinitrogen trioxide is prepared is by cooling a mixture of equal part of nitrous oxide. Nitrous oxide is N2O, and nitrogen dioxide. Nitrogen dioxide is NO2. So when you have N2O and NO2, you are going to have, if you have NO and NO2, you are going to have N2 or O3 molecule. That is dinitrogen trioxide. So that is how to prepare it and cool it to minus 21 degrees Celsius. So it is always in liquid or solid state. So when it is not stable, if it is heated, then we have refraction to make sure of this. These are the things these are the compounds that formed it. So when you heat it, then they go back to the compound. So when you cool it, then they combine again, like we have here now in this dinitrogen tetraoxide, like something like this. That is what we have here. So if you look at this, the way we used to calculate our electronic our oxidation state. Oxidation state is 3 here now. Oxidation state here is 4. Then we have another one is 1, another one is 2. So now another one that where is the oxidation state is 5 is dinitrogen pentaoxide. This is N2O5. This nitrogen pentaoxide is a white solid. It is very solid and is from the dehydration of nitric acid by phosphorus 5 oxide. So if you have a nitric acid, this is a nitric acid, you have phosphorus 5 oxide, this is phosphorus 5 oxide. So when you have a reaction between two of them together, this one is a good dehydrating agent. It's an hygroscopic substance. It's a good dry agent, rather. That is a more reasonable way of calling it. So when you have this, it's going to remove the water. In this case, instead of to now be the water, that water will now react with this PO4 to form something like phosphate acid. It's not a stable acid, so we are going to have something like this. So when we have this dinitrogen pentaoxide, that is our heme of this reaction, it is very, very unstable above room temperature. It decomposes to N2O4 and O2. That is what we have here. So let us look at some properties of nitrogen oxides. The oxides of nitrogen 3, 4 and 5, as in when we have the oxidation state of nitrogen to be 3, 4 and 5, react with water and form some oxide acid. All these oxide acids are called acid anhydride. We have known, as in we have heard about acid anhydrides before. Example is this: when you have N2O3, that is the nitrogen trioxide. It's an acid anhydride of nitrous acid, that is HNO2. So N2O5 is an acid anhydride of nitric acid, that is HNO3. So if you look at this, N2O3 is when oxidation state is 3, N2O5 is 5. So if you have NO2, that is when you have oxidation state of 4. So an acid anhydride to another acid, that is another acid is HNO3 also. So all these, they are acid anhydride to some acid, that is when they react with water. So N2, that is nitrogen 1 oxide now, is a strong oxidizing agent. It only decomposes when heated to form nitrogen and oxygen. Nitrogen oxide now, that is when the oxidation number is 2. It can act as both oxidizing and reducing agent depending on the environment. So if it is in the midst of phosphorus now, it acts as an oxidizing agent because it's going to oxidize this phosphorus to form P2, that is phosphorus trioxide, and nitrogen will be reduced. If it's with a highly electronegative element, electronegative element acts as an oxidizing agent, and this one is going to act as a reducing agent in this case now to form this. So for nitrogen dioxide now, or the nitrogen tetraoxide, anyone, the two of them are good oxidizing agents. If you look at this now, there is oxidation of CO to CO2, and this one itself is reduced. That is an oxidizing agent. There is oxidation of this now into oxidation of oxygen here into water. The heat itself is reduced. So in that case, it has served as oxidizing agent. Those are the things that we need to learn for today. But before we go, let us try to look at what we have learned as form of revision. So nitrogen is a major component of air. We have said it is air contains almost 78% of nitrogen. It is unreactive under normal conditions because of the 3 bonds, that is in its atom. Nitrogen can have an oxidation state of -3, but can form compound having an oxidation state of -3 up to +5, even +5. I said it -3 or these 3 too, they are not that stable, but we are not going to concern ourselves with that. It has unpaired electrons, which are responsible for coloration in some of its compound, and I've explained that before. It is produced primarily from fractional distillation of liquid air. So let us try to look at some examples. This one is a 2002 JAM question, 27. The most important use of hydrogen is the dash. This question is not today's question, but because we have not talked about any exercise when we are talking about hydrogen, that's why I brought this equation. In the hydrogenation of oil, let us try to look at the importance of each of these elementochemical industry. That is when we now conclude on our answer. If we look at each of these, the manufacture of ammonia, in fact we have been hammering on it, is a very, very important reaction, a very important reaction in the industry. So out of all this reaction, ammonia is the most important because it's used to produce fertilizer. So if you produce fertilizer from it, even we can also use fertilizer for farming. That is, we know the benefit of farming. So that is the most important use of hydrogen. This reaction, we have encountered it today, so you don't need to look at the note before you can do it. We have done balancing equation before. Just look at it and see that this is the answer. When steam is passed over red hot carbon, steam is water in gaseous form. When it is passed over red hot carbon is something like activated carbon. When you try to activate the carbon, don't forget carbon acts as a reducing agent. So when you have things like this, you don't need to look at the answer first. Something must have rang a bell in your ear that, okay, what is the information am I to get here? Steam is water, then carbon is here. What is the essence of carbon here? Carbon is to act as a reducing agent. So now the substances produced are dash. So now look at the answers. Hydrogen and carbon trioxide, you write it down. Is it like that? If it is hydrogen and carbon, anything you write that is it, then that is your answer. Here is the answer in this case, because the water, oxygen will be removed from the water and added to the carbon. So we have carbon monoxide there, that is carbon trioxide, then hydrogen will be there. Thank you very much for listening. Next video is going to be on oxygen and its compound. Thank you very much for this, and God bless you.